Hello everyone, here's a new video on how to configure the Fanuc robot to extend its I/O through Ethernet IP using a Festo CPX-AP-I architecture. So what we're gonna do today, and basically let me show you the picture of the topology, is we're going to be using a Fanuc 200iB. This is the one that's shown here in the picture. And we're going to connect directly to the controller with Ethernet IP. By the way, if you go this route, you have to make sure that you purchase the Ethernet IP, I guess, add-on or installation. I don't know how Fanuc calls it, but it's basically like an additional license that you have to get for your robot controller. So once you get that, you're going to be able to just use one of the Ethernet ports on the Fanuc controller and plug into there with an Ethernet IP device. Anyways, so as you can see on the picture, we're going to connect from that Fanuc controller to head module, which is an Ethernet IP module. Then from there, we're going to be able to branch out or to connect more modules, and these can be digital inputs and output modules, analog modules, valve manifolds, and IO link modules. So if I show you right now, I can show you the architecture that I have here in front of me, and you're going to be able to see. So as I mentioned, this green cable right here is the one that's coming from the Fanuc controller. Then this is the Ethernet IP module. The other cable is just going to my the one that's going to the top. Then these cables right here are going to my modules that are connected subsequently. So first I have a manifold, then I have a 4 digital output module, and then next I have an IO link module. Then from this IO link module, I have this ugly connector over here that's connected to this electric actuator. So this is basically just a kind of like a piston rod actuator that allows me to extend and retract. And that's basically the topology. And you can see here it resembles to what I have here in the picture. Now, let's go and start looking into how we're going to do this. So first things first, I guess, you have to, I'm going to be using the, I guess, the web visualization for the Fanuc pendant. You can always do this directly on the pendant itself. So the first thing that you have to do is, of course, you got to know which is the IP address of your Fanuc robot. For that, and bear with me because I'm not a power user from Fanuc or whatever, but I should be able to navigate my way around. So first you go to menu and then setup, and then you click on type. And then once you're on type, you're going to go to host communications. Then here under TCP/IP, you're going to hit enter. And then here you're going to have the IP address of your robot, in this case 145, right? So as you can see, I already knew this IP address because I'm connected to it with my computer. But anyways, this is important. So my robot is at 145. Then up next, what we have to do is we have to set an IP address for the let me show you. We gotta figure out what's the IP address for this module. Now, this module out of the box comes in DHCP mode, meaning that it's expecting to be assigned an IP address or a dynamic, it's in DHCP dynamic IP address. So there are two ways of setting an IP address to this device. One of them, you can download a software that's called Festo Field Device Tool, like so. You can download this from the Festo website. Basically, what this does is that it scans anything on the Ethernet network from your computer, and then from here you can assign an IP address. Now, right now I have already an IP address assigned to my module, but as you can see, it already scanned the network and it's being shown here. My module is at 1.5. Oh, if only I shared my screen, right? There. So this is the software, Festo Field Device Tool. And basically what I did is I just opened the software, click scan, and there it is, 192.168.1.5. Then from here, if this didn't have a static IP address, it's brand new out of the box, it's going to come in DHCP, you can right click on it and then click on network, and then here you can assign an IP address, okay? Now, why is mine not showing it like this? There's a reason, because I didn't use this software to assign an IP address. I actually did it by using some rotary switches. So what I'm gonna do is I'm gonna show you those rotary switches. So we're gonna go to festo.com, and then I'm gonna type in the part number for that, CPX API-EP. There we go, Ethernet IP interface. Then support and downloads, user documentation, and we're gonna look for this one specifically, English. And if I scroll down, keep scrolling down, you're gonna see here, right here, on this is a cover. So on number 2, it says rotary switch cover, right? So if you open this rotary switch cover, you're gonna see you're gonna have access to these rotary switches. By using these rotary switches, you're gonna be able to assign also a static Ethernet IP address, which if you want, for example, 5, as it was my case, you have to set the rotary switches to 305, okay? And this is because the IP addresses for Ethernet IP begin at 300. So specifically talking about the switches. So again, if I want to set 192, and as you can see here, this assigns the last octet. If I want to set 192.168.1.5, I have to set these rotary switches to 305, okay? If I was working in a different architecture and I was doing this with Modbus, I would do 605, which would be ultimately 192.168.1.5. Okay. All right. So that was a little explanation of how the IP address is assigned. Now, the next thing that we have to do is we have to go and configure the Ethernet IP connection. So now we click on Menu, I/O, and then under I/O, you click under Ethernet IP. And then here you're going to have all of the Ethernet IP connections. So in my case, I'm going to use connection 2. You can change the name of this connection. So I'm going to set it to Festo CPX-AP-I. That's the name of the module. I'm going to hit enter. So there it is. You can see the name down here. It's too long to display here, I guess. Now you have to change this to scanner. Okay. So scanner. And then this is pending. Some changes that you make here, you have to do a power cycle in the controller to take those changes. So those are the first things that we have to do. Let's ping it. Oh, invalid host. Oh, I guess I gotta maybe cycle power. Well, before I do anything, let's click on configure. So let's configure this connection too. Here we're gonna set the IP address. That's why, of course. What is it gonna ping, right? So here we're gonna set the IP address, and what IP address I'm gonna type in here? The one that I assigned to this module, right? Remember that I did it with the rotary switches. So that's the IP address that you would use there. In our case is 192.168.1.5. We do that. I wonder if it lets me type it now, ping it now. So let's do previous, and let's try to ping it. Yeah, there you go. That's why it didn't let me. Okay. 192.168.1.5 succeeded. The ping succeeded. All right. That's good. So now I'm going to click enter. No. That's to change the name. I want to configure this. Now, okay, vendor ID, device type, product code, all of this. Where do I get all of this information from? Here, what we're going to do is we are going to open a new window here. So I'm going to open a new window, and I'm going to type in the address for that module, CPX-AP-I module. Let's see. So now all of the modules, because I'm online right now, so you can see everything is connected and powered on, all of the modules are going to show up here. This is really good. Everything is in green. Everyone is happy. Okay. Now there's a couple of things here. Within this web page, what you can do is you can have access to, excuse me, to parameters, for example, for the modules. For instance, this valve manifold, which parameters does it have? Well, for instance, behavior in fail state. What do I want the manifold to do if it loses comms? Well, do I want it to reset the outputs to 0? Or maybe I want the outputs to remain on the state that they were in when before it lost connection. So this is the type of parameters that you have. There are some modules, like you can see here, they have just a very few parameters, but there are some modules, for example, this IO-Link module that has a bunch of different parameters, right? In my case, for example, since I'm using, oh, and I did it again. I was talking while I was showing the hardware. Again, this is where you click the parameters. So here, parameters, reset outputs. This is what I was talking about earlier. Um, this is the additional other parameters. This is the IO-Link module. So as I was saying, in my case, I have all of these different parameters for IO-Link. And what I'm doing now is I enable the port 0 to IO-Link auto start, basically because this port 0 on the IO-Link module is the one that I'm using to control this IO-Link device, right? So if you wanted to enable another port, you could do so here. And there's a bunch of other parameters that you can have access to. There's a variant here that you can set. And let me, I guess, let me show you that. Stored parameter. Let's see. When you want to change something on this module, it's going to ask you for a username and password. And the username and password, I think we can see this on the user manual. We search for password. The username is admin, and the password is a product key that is printed on the device. Where do I see this? If I go to the device and I turn it sideways, well, you're not going to be able to see it there on the camera, but right here there is a number, okay? So if I wanted to access the web server, so in this case, access some, I guess, changeable things, I'm gonna have to type in that number. In my case, is J4 5Q4. So I typed in the password now, and now I have access to the store parameter function under configuration store parameter. What I'm going to do is, I was working on this before, so I'm going to delete everything so I can show you. Restore default parameters, so submit. Okay, so let's go back to AP right here. Okay, so now if we take a look here, everything is set back to defaults, right? So again, I need to set that first port to IO-Link auto start. You can see parameter write success. Then down here, this is the variant that I was talking about. If we take a look at the user manual for the IO-Link module, and remember, this is just because I'm working with IO-Link, okay? So CPX-AP-I for IOL. Just want this to be clear because it could be a potential gotcha. Support and downloads. Let's take a look at the documentation for that particular module. Down here, English. Here, table 8.1. There are multiple variants, as you can see here, right? You have multiple options. Depending on how many bytes you want available on each port, you select the variant. My point is never use the OE variant with Ethernet IP, okay? Always use it with only, if you were using Profinet, that's fine, but always use the non-OE. So for instance, I'm gonna use 32 because EP is right here, but never use OE when you're using Ethernet IP communication. That's the important point to mention here. So I have it set to variant 32 now, non-OE, right? So variant 32. Now, once I set that, what I'm going to do is I'm going to store these changes. I'm going to store them on the module. So I'm going to go to store parameter again, and I'm going to say submit. So store current parameter values, submit. So now the parameters were saved. They were saved on this module, okay? Perfect. So now we can go back to AP. All right, so where were we? We were, oh, I guess this timed out. Let me open it again. We were right here. We said how do we configure these things? So vendor ID, device type, and product code. Where do I get that information from? From the EDS. And you can actually get the EDS directly from this web server. You click on Ethernet IP EDS file, and that's going to download a file, the EDS file in a zip format. I'm going to open that. And now there are two EDS files here. We are using CPX-AP-I, okay? Not A, I. This is this topology that we're seeing here. So I'm going to open this with Notepad. Notepad, okay? So now we have our Notepad here. Now let's take a look at what it's asking from us. Vendor ID. So vendor code is 26. That's what I need here. 26. Device type. So product type 12. Product code 14057. 14057. Input size. And this, it says that it's in words. Okay, and actually I can close this for now. This says that it's in words. Okay, there's an important thing to mention about this. If I click again on Ethernet IP and I click on assembly view, this is pretty nice because it'll give me the whole mapping for everything that I have connected right now. So basically the head module, this module, the Ethernet IP module, identifies every other module that is connected to it. And it knows how much I/O each module occupies. So if I click again, assembly view, so I have inputs and outputs. And here you can see, for example, these are my bulb manifold. This is my bulb manifold. All of the coils are listed here. Then I have some outputs and then I/O link. So this is pretty nice because what I can do from here is this is telling me how many bytes. Okay, so it's telling me that the input instance it's 100, and then the input size it's 133 bytes. I recommend that you change this from words to bytes. Where do you do that? I believe you can click here on advanced, and then maybe not. Let me see here. Oops. Let me see. Maybe it's up. Yeah, there we go. You click advanced, and then here you have the option choice. We change it to 8-bit, so now it's in bytes. Changes will take effect after power up. That's fine. What else do we have here on advanced? I'm going to change the reconnect to true. So I want it to reconnect. What else do we have here? I'm not using quick connect. I'm going to set it to unicast. Let's leave it as is now, for now. Okay. So the input size, we said that we have 133 bytes. So we're going to set this to 133 bytes for inputs and 133 bytes for outputs. Now, I want to be very clear about this. This is going to depend on what you have. Okay, if you have more modules than I do, or if you have less modules than what I do, you might have a different size of I/O, right? Okay, now the RPI, you can leave this as 32. It really depends on your application. Usually I set it to 10. I don't remember if I tested 32. It should work fine, but this depends on your application. It's basically the cycle time of the communication. Then assembly instance input, we mentioned that the assembly instance is shown right here. So in our case, it's going to be 100. And then the assembly instance for output is going to be 101. Configuration instance, I just need to specify the configuration instance, and this is shown all the way down here, 140. 140. Now, as you probably noticed there, it says 400 bytes, but in Fanuc, it doesn't ask us for the configuration size. So we'll just leave it as is. So it looks like we're ready here. Let's see. Let's double check everything. 12, 14, 133. Perfect. So let's say previous. So we set this to scanner. Let's actually switch this to true. So after we do that power cycle on the robot controller, this communication should be enabled. This is pending right now. And inside of the configuration, everything looks fine. I think that we're ready to go. So let's do that now. I'm going to power cycle the robot now. Just give me a second. There it is again. It's back online. All right. So let's see if now the communication is running. So we go to menu, and then we go to I/O, right? Then type Ethernet IP running. This is what you want to see. If you don't get a running status, that means that you have an issue with the robot communication. So, for instance, at one point I had the wrong product code, and it was giving me I think it was like some sort of error, like yeah, Ethernet IP error. I don't remember. At one point I had like a forward open message error, Ethernet IP forward open message error, and whatnot. But this is exactly what you want to see running. This is good. So now let's do some I/O check. And actually, I have a fault right now on my architecture here, my topology. But I know why that fault is. I'll clear it here in just a second. Let me just move this little bit out of the way, I guess. If I can get these cables. Okay. So here's where all of the I/O is displayed. And if I recall, all of these was automatically populated for me. So the outputs are here, the inputs are over here. Now, how do I know which ones are which? I would imagine that the robot has some onboard I/O and maybe some, I don't know, some additional extensions that you can do. I don't know. But I know that I am working on rack 89 slot 2, okay? How did I determine this? If I click on type and then I go to, again, to Ethernet IP, and I click here on my Festo CPX API, we see that this Ethernet IP list is on rack 89, and specifically my Festo CPX API connection is on slot 2. That's how I was able to determine where was I. So I go back to digital, configure. So these are my outputs. My inputs are in a different range, but that doesn't matter. It's also 89, rack 89 slot 2. So let's see, digital outputs here. So these are my first outputs, right? So if I go to the outputs, what is the first bit? It's the coil 0. So remember, under Ethernet IP, under Ethernet IP assembly view, outputs, my first bit is the first coil. So let's try that. I'm gonna go back to here, and then let's do monitor, and let's try to toggle this first coil. So switch it on. Yes, and I actually heard the coil click. On, off, on, off. I'm gonna show you the coil, so you can see the first coil on, off, on, off. And this is now being controlled from the Fanuc robot, okay? Up to now, this is very, very simple, right? We already have some control. Now, if I wanted to check inputs, I'm gonna do a little trick here. So I'm going to do a jumper. Let me do a quick jumper here. Hold on a second. Okay, so I just added this jumper here. You can see it, right? So I just added that jumper, and I'm gonna just put it in and out. Let me switch to the inputs and outputs. Actually, um, here, select it, and then monitor, so it goes all the way down. You can see that now it's on, it's off, and I don't know if maybe you can see the LED right next to my finger. on off. So I'm going to show you now the teach pendant. You can see it toggling on and off, right? So this is great. We have some I/O going on, right? Perfect. Okay, up to here, you can just take it from here on, right? Like I covered most of the stuff for I/O. Pretty simple to do. I could finish the video right here, but I'm actually going to record another thing, and I'll probably make this part 2. How do we deal with I/O devices here? So you probably see